So the time right now is 2:17 on Thursday the 16th. Alright, so the question, so we have a light bulb with two strings with tension in an elevator. So the first question would be, what is the tension in each wire? So in order to do that, first we need to find the angle. So let me just draw out the diagram. Have that's 1 meter right there. You have a light bulb, two strings. Like that. And it helps to just cut this in half. So we know this is 0.8 meters. So let's find what this theta is right here. So if we just do a little box over here, that would be 0.5 meters because it's cut in half. 0.8 meters. And for this you would use cosine. So inverse cos of 0.5 over 0.8. That would give you an angle of 51.3 degrees. So let's keep that in mind. So let's take a look over here. We're trying to find the tension, which is these two right here, tension. So our x component for our tension is going to be the same because it's not moving horizontally, so we don't have to worry about that. But what we can say is 2ty, the y component of the tension, it points up. There's one over here, and at the same time there's one over here, and they are both holding up f of g, which is pointing down. So because they're the same tension, we're just going to label it 2ty. We don't have to do t1, t2, any of that stuff. And that's going to be equal to f of g. So, ty, so if our angle is right here, this would be ty also. Because remember, if it's a vector, you can just move it. It doesn't matter where it is. Ty. So as you can see, that would be using the property of sine. So ty is equivalent to just t sine of whatever angle this is. We found it to be 51.3 degrees and mg. So 2t of sine 51.3 degrees equal to, and the mass of the light bulb is 0.25 kilograms times our acceleration due to gravity, which is 2.45. And now we want to just isolate for t, so we can divide 2 over and divide the sine 51.3 over. And our tension is 1.57 newtons. So that's your answer for the first one. Part B, the elevator starts accelerating upwards at 1 meter per second square. What is the new tension in each wire? So we just set up newtons for this. Just like that. So remember over here on our forces, we have our 2ty holding up with our fg pointing down, and that's just equal to ma. Remember, let's get rid of ty for t. So then we'd have to do 2t again, sine 51.3 degrees minus our f of g, which is 2.45. 2.45, because that's just 0.25 times 9.8 equals our mass, which is 0.25, and then our a is just 1. So let me add that over 0.25 plus 2.5, yeah, 2.75 equals 2t sine 51.3, and then divide by, we want to isolate for t, divided by sine 51.3, and we get a tension of 1.76 newtons. And that's how much it would be in an elevator that's accelerating upward. Let's look at part B. I'm just going to use new side, make it clean. Part C, what is the tension in the wire? But this time, as you can see, we have 4 strings holding it up in a 1 by 1 squared. So let's draw a little diagram first. We have anchor points right here. Our light bulb is right here with strings going this way. This is like a bird's eye view. 1 meter that way, 1 meter this way. So as you can see, instead of using the 0.5 we normally use for up here, we're gonna have to find whatever length that is right there. So let's do that. In order to do that, we know this half is 0.5 and this half is 0.5 because we know it's a 1 by 1. So if I draw it out, theta's right there. That's 0.5, that's 0.5. So just apply Pythagorean theorem. We do 0.5 squared plus 0.5 squared equals RC squared. 0.5 squared plus 0.5 squared, and then square root that. RC equals 0.707. So that's actually going to be our top height. So now if you can imagine, .707 is up here, and the length of the string, which is 0.8, right there, and then we have a light bulb hanging down right there. So then this time, because we have 4 tension, we're going to do 4 Ty. Again, we don't need to do T1, T2, T3 because they're all the same. Equals to Fg. For, again, we want to find T, not what Ty is, and we know that. Oh wait, we should probably find the angle first. That's what I did that for. So theta's right there. So we want to do inverse cosine of 0.707 over 0.8. That gets you an angle of 0.707 divided by 0.8. 27.9 degrees. So yeah, that makes, so this means this would be our Ty. So our T, which is right here, would just be T sine of 27.9 degrees equals mg. Our mg is just the mass, which is 0.25 kilograms, times our acceleration, which is 9.8 meters per second squared. We already did that. That's 2.45 equals 4t sine of 27.9. Let's isolate for the t. So it's divided by 4 divided by sine 27.9, and we end up getting 1.3 as our tension, 1.3 newtons. And then the last part asks for, it's the same thing as part B, an elevator moving upwards at 1 meter per second squared. What is the new tension? Let me just move this up a little bit. So, set up newtons. We have on this side the forces, we have 4Ty minus F of G equals MA. Again, we're trying to isolate for T, not Ty, so let's convert Ty to T. Ty is just T sine of 27.9 degrees minus, remember our F of G is 2.45. Again, that's just 0.25 kilograms times 9.8 meters per second squared. That's 0.25 kilograms. And then it told you it was accelerating 1 upwards, 1 meter per second squared. So let's combine like terms. So 0.25 over here plus 2.45. Get 2.7 equals 4t sine 27.9. Let's isolate for the t, so let's divide the sine 27.9 over, and then divide by the 4, and you get your t, which is 1.44 newtons. And that is it.